Hi, so today we're going to go over some of the concepts that we've talked about in previous units. Specifically today we're going to be looking at unit rates and proportional relationships. So the first thing that we're going to look at is unit rates and unit price. Now remember with this, there's two really important things that you want to kind of look for. Whenever you see this word per and whenever you see the one. Okay, for every one, something along those lines. So that essentially means that you're going to be dividing. So if we look at like this problem, I haven't even read it yet, and I can see this word per, and I know that I've got money per kilograms, and that per kind of means divide. So I know that I want to take my money amount and I want to divide it by my kilogram amount. So let's go ahead and read it. The first one says, a 9-kilogram bag of animal feed costs $45.45. What is the unit price per kilogram? And again, we see this word per, so we have price per kilogram, and that means divided by. So we want to take our price and divide it by our kilograms. So our price here is going to be $45.45, and we want to divide that by how many kilograms? And we know that we have 9. Now, when we go ahead and do that, when we have $45.45 divided by 9, we end up with $5.05. Now that's per kilogram. So that would be our answer. So that means that every kilogram of animal food that they buy, they're spending $5.05 on it. Now sometimes they won't always use the word per. Sometimes they use for every one or for one. And that's kind of the same as saying per. So that means that we're going to divide whatever we want one of. That's going to be the second thing that we divide by. So if we look at this here, we have acres cleared and we have 2/3, and then we have days is 2, and we want to know how many days does it take Tim to clear 1 acre. So that means we want to divide acres second, so we're going to put days first. So here I have 2, and I'm going to divide that by 2/3, so here I have a complex fraction. Remember, we can write this just as 2 divided by 2/3, and then to write this, I want to multiply by my reciprocal or keep change flip. So I'm going to write this 2 as 2 over 1, and just because I know that I'm going to be multiplying by a fraction, so that's a little bit easier to look at. And then I'm going to change this to multiplying, and then my reciprocal of 2/3 is going to be 3/2. Now here I want to see if I can simplify anything, get rid of any common factors. I know that I can get rid of both those 2's and divide them both by 2 to make them 1's. Since I have 1's at the bottom, I know my answer will be a whole number, and then I have 1 times 3, which just gives me 3. And again, that's going to be, I did days divided by acres. So it's going to take me 3 days per acre. Okay, so next we're going to talk about how we can use these unit rates that we just talked about to solve for unknowns. So here it says, if 5 pizzas cost $60, how much will 9 pizzas cost? So you can do this a couple different ways. If I think about, all right, well, I've got $60 for 5 pizzas, I can figure out how much I need for 1 pizza. And I know that to get from 5 to 1, I'm dividing by 5. So at the top, I also want to divide by 5 to make equivalent fractions. 60 divided by 5 gives me $12. So that means that each pizza is going to cost $12. So then I can say, all right, well, for 9 pizzas, I'm going to take that number and I'm going to multiply it by 9. And I see that that's going to be $108. Total for 9 pizzas. So 9 pizzas will cost $108. You can also set up a proportion and say I'm going to do money over pizzas and say, well, I know that $60, it's $60 for 5, and that's going to be equal to some number for 9. And if we want to solve for x here, you can multiply the 2 across that you know. So we can multiply 60 times 9. And that gives us 540. and then that's going to be equal to 5 times x, and then we can divide both sides by 5, and we're left with x equaling, again, 108. So 2 different ways that you can solve that. There's a bunch of different ways you can solve that. This is just 2 options. So sometimes they'll just give you the proportion like they did in this one. It doesn't really give you context. So you need to be able to solve that. Now you can figure out kind of your unit rate and then multiply that out, kind of like we did here. Or you can do the cross multiplying and solving that we showed down there. For this one, honestly, the cross multiplying and solving is probably going to be easier, but both ways would be fine. So here, again, you want to multiply the 2 that you know. So we'd multiply 12 times 8, and that would give us 96. That's going to equal 7k, and then divide both sides by 7, and that leaves us with k equaling, oh man, something crazy. It's going to equal about 13.7 when you solve that. Okay, so now we're going to kind of move on. Remember, after we talked about unit rates, we talked about proportional relationships, and there's 3 different ways that you can kind of look at proportional relationships and that they can be represented. They can be represented in tables, they can be represented on a graph, and then they can be represented in an equation. And all 3 ways, depending on the circumstance, you know, could have different benefits, but you need to be able to identify certain things from each of the different ways. So what specifically we're going to talk about is how you can tell if they're proportional from each of these different kind of ways that we're looking at. What our constant of proportionality is, remember that's kind of your constant multiple of x to get y. So what are you multiplying x by every time in order to get your y variable? That's your constant of proportionality. And that only really happens when you have a proportional relationship, or else it would be called slope, which we'll get into a little bit later. And then an equation, if you need to derive an equation from a table or a graph, but obviously if you already have the equation, then we're not going to be looking at that. So first let's talk about a table. Now in order to find our constant of proportionality, we're going to kind of talk about that first. You're going to do y divided by x. Now the reason that we're talking about that first is because if you have the constant multiple every single time, that means every time you're multiplying x by the same thing to get y for all the different data, then that's going to make it proportional. So we kind of can find our constant of proportionality, and that'll kind of show us if it's proportional, because if we divide y by x for all of these and it's the same number, then that means it's going to be proportional. But if we divide y by x for all these and we get all kinds of different numbers, then that means that it's not going to be proportional. So if we look at this table, I'm going to first take 10 divided by 2, my y value divided by my x value, and I get 5. Then the next one, I'm going to take 20 divided by 4, and I also get 5. And then finally, I have 30 divided by 6, and I also get 5. Because I got 5, 5, 5, all of them are 5, that means that yes, this is going to be proportional. Okay, you can also look at it and say, okay, I see that I have 2 here, and I know 2 times 5 gives me 10, 4 times 5 gives me 20, and 6 times 5 gives me 30. So that's another way that you can say, well, yeah, it's proportional because every time it's the same constant multiple. Now our constant of proportionality, again, is that constant multiple. So here we have 5, 5, 5, so our constant of proportionality is going to be 5. Now, sometimes we refer to this as k. Now the equation, remember, is y equals kx, or y equals our constant of proportionality times x. So our equation here would be y equals 5 times x. Okay, now let's talk about from a graph. Now from a graph here, we want to look for a straight line that goes through the origin. So because this is a straight line through the origin, yes, this would be a proportional relationship. Now our constant of proportionality is kind of that for every 1. So what we want to do is go to 1 on our x-axis, go up and see where we're at. So in this case, our constant of proportionality is going to be 20. And so our equation would be y equals 20x. Okay, now from an equation, we have two options here. Now, if you look at these, we don't have anything being added or subtracted to each of these. We just have y equals some number times x for both. That's how you can tell if it's proportional, because both of these were also proportional. So if we look at these, this one looks like that, so this would be proportional, but this doesn't, it has something being added in addition. So this one would not be proportional. We're not going to do these parts. Now, because this one is proportional, we can come up with our constant of proportionality, which again is just that number right before x. So in this case, that's going to be 11. Now we're going to switch gears a little bit, and we are going to look at percent. So first, remember our percent equation is part equals percent over 100 times whole. And remember, this percent over 100 is essentially just making that percent into a decimal. So this says you scored 95% on your math quiz. The quiz was out of 60 points. How many points did you get? So first you have to identify what are you looking for. In this case, we're looking for the part, so that's going to be our variable. And then I'm going to draw my line, my 100. So that means 60 is going to be my whole amount, and 95 is my percent. Now I can go ahead and say, well, I know 95% is 0.95 as a decimal, and I'm going to multiply that times 60. And that means that I get 57 for x, so that means that I got 57 questions correct on the math quiz if I got a 95% of them correct. Also keep in mind, whenever you're talking about percents, since this is talking about I got 95% correct, then that means that whatever my part is talking about is also how many I got correct. So whatever the percent's talking about and whatever the part is talking about are going to be the same thing. So we're going to use the same equation here, but now we're going to be talking about percent markup and markdown. The first one it says, if a watch costs $40 and you must pay $6.5% sales tax, how much will tax be? Okay, so this one you have to kind of understand that we're looking for a percent, but actually it's just asking us for tax, but I want you to also find the final cost. We're going to change the question a little bit. So here I see, again, I want to use this part equals percent over 100 times whole. So I don't know the part amount. I know my percent is 6.5%. So I'm going to put that over 100, and my whole amount is going to be 40. Now, because my percent here is 6.5, and that's talking about how much I'm paying just for sales tax, my part here is just going to be the amount of money that I'm paying for sales tax. So I can go ahead and simplify this down. I have 6.5 divided by 100, which I know that that is 0.065. I multiply that times 40, and I get that x equals 2.6. So that means that I'm paying $2.60 in sales tax. But if I want to find the final cost, I need to add that back to the 40. So at 40 plus 2.6, which means that I would be paying $42.60 total, including tax. Okay, now my next one here we have a discount. So again, we're going to start with our part equals percent over 100 times whole. So I don't know, it says Charlie bought a pair of shorts at a store when they were having a 45% off sale. If the regular price of a pair of shorts was $24, how much did Charlie pay? So I have x equals 45 over 100. And then my whole amount is my original price, which is going to be 24. So I can do 0.45 as my percent as a decimal, multiply that by 24, and that leaves me with 10.8. Now my percent here is how much off, or how much I'm not paying. So what I need to do then is take my 24 and subtract my 10.8, because that's how much I'm not paying my discount, to figure out my actual price. So he actually paid $13.20 after discount.